Okay, we're going to talk about transformations of functions today, and I'm going to start with this graph right here in blue. This is a linear function where it's the parent function, y equals x. But I'm going to write that in this point-slope form. So over here, I have this in point-slope form where for my y1 and my x1, I've put in the 0.00. So down here, I'm going to highlight this as 0.00. It's right here at the origin. So when I'm dealing with this, I'm going to start looking at this in terms of point slope. So if I have a point slope equation and I've chosen the point 0, 0 for my point to plug into the equation, this is the graph that I would get, and I have this point on the line. Well, I want to talk about how this point changes, and so I'm going to change this point to go to here. Okay, so I want my 0, 0 to move to this point of negative 5, 3. And I want to change my equation, my point slope equation, to have this 0, 0 no longer be that, but be this point instead. So when I look up here at this equation, I say, well, I'm going to plug in my negative 5 for my x. I'm going to plug in my 3 for my y. So this is my x1 and y1. So my x1's here, my y1's here. When I plug in negative 5, this is really plugging in, so I've got a minus negative 5. So when I'm doing this, and I'm plugging in my, for my point, my x1, and then my y is 3, this really is going to be a plus, right? So a negative negative makes a plus. And I can graph this. And the way that I would graph it is I'd plot that point, and then I'd count my slope. I'd plot the point and I'd go up 1 over 1, up 1 over 1, up 1 over 1. And that's going to give me this line from the point slope equation. Okay. Well, this is not how we talk about how this 0, 0 moves to this point right here. So I want to know how the 0, 0 moves from that origin to negative 5, 3. We talk about it in another way. And the way that we do that is we change our point slope equation, so this purple line right here, we're going to change the way we write it. And what I do is I take this negative 3 and I'm going to add it to both sides. So, or I could circle it and move it over to the other side and say it's going to change signs when it moves. Or I can say I'm adding 3, I'm adding 3. And that's going to give me this equation right here. And if you notice, my purple line and my green line are now living on top of each other. So there's my purple line, and when I graph my green line, it's sitting right on top of my purple line because it's the exact same thing. I've just rewritten the equation in another way. And the way that we talk about this particular equation in this different way is instead of saying that this is my x1 and this is my y1, I call it h and k. So we're going to change our the way we talk about this. Instead of saying x1 and y1, we're going to say h and k, because we're going to use h and k for all these other functions that we're going to start drawing in this class. Okay, so I've got this derived. When I'm drawing this equation right here, so when I have this guy, this is really, I'm going to rewrite the 0, 0 this way as well. So let's say I've got this. I'm going to take this out, put a 1 in. So what I've really got is this form of my h and k where my 0 is here, my 0, 0 is here, and I've moved it to negative 5, 3. And that's what it looks like when I've moved it to negative 5, 3, and we call the 5 the negative 5 my h and my 3 my k. Okay, so that's what we call it. Their linear functions are not the only functions that we have. We also have quadratic functions. So I'm going to, take these off my screen and start talking about things that are quadratic. And the difference between a linear function and a quadratic function is like when we did this guy, this is really to a power of 1. Right? We don't write down a power of 1, but it really is to a power of 1. And when we get to quadratic ones, we're going to have it be a power of 2. So when I start doing this guy right? This is a power of 2. So if I did this one up here, this would also be to a power of 1. So I've got my 0, 0, but my HK form is going to be a power of 1. And then when I do my quadratics, I got my 0, 0, and I've got this to a power of 2. And I'm going to draw that one in. Okay, so I'm going to zoom in just a little. Whoops. So I've got this 0, 0, and again, that 0, 0 is moving to negative 5, 3. Okay, so I know that I want to write that in a way that says, how did it move? I'm putting it into this form where I've got this h and k, but except I don't have a power of 1 anymore. I now have a power of 2. And when I have a power of 2, it changes the shape of the graph. So when I had a power of 1, I had these guys, and they were linear. There are these straight lines, and I still had my 0, 0 moving to negative 5, 3. And then when I change the power on those to from a 1 down to, up to a 2 down here, it makes them quadratic. It makes them curved. So we have these parabolas. But I still have these guys changing the same way. They're still in that HK form. So it's this HK where I did have a power of 1 and now I have a power of 2. And we're going to talk about how those move. Like how much does it move on the x-axis and how much does it move on the y-axis. So when I'm counting these out, I want to know how did this move from 0, 0 to negative 5, 3. So I'm going to count it. On the x direction, it's moving 1, 2, 3, 4, 5 to the left, and then it's moving up 1, 2, 3. Okay, so we're talking about how it moves. It moves 5 to the left, it moves up 3. So we have a name for these things, this 0, 0 at the bottom of our parabola, and this negative 5, 3 at the bottom of our parabola, and we call that thing the vertex. And this is really vertex form. Okay, so I've got this vertex, how my 0, 0 changes from to negative 5, 3. And I want to talk about a different param function. And I'm going to have the exact same equation as I had before, except for instead of having a power of 1 on the outside of that parenthesis group and a power of 2 on the outside of the parenthesis group, I'm now going to change the parenthesis group to absolute values. So it still has, my 0, 0 and my 5, 3, but I've changed my parentheses and that power to just these absolute value symbols. Okay, so I'm going to take my parabolas out. I'm going to put my absolute value graphs in. Okay, so my parabolas were U-shaped, and so I'm going to put these back in here just for a second. So I had these U-shaped parabolas. And then when I change the parenthesis and the power of 2 to just absolute values, I get these V shapes. But I still have my 0, 0, and I still have my negative 5, 3 because I have my 0 and that 5 and 3. And inside parentheses, right, this was negative 5, but it's opposite inside. And my outside was 3, and this is the same sign. So I've got this negative 5, 3. This is also called my vertex of my parabola, and this right here is called the vertex of my, of my absolute value. So the vertex of my absolute value and the vertex of my absolute value. So what I want to do is I want to talk about the pattern we see in the equations. So I'm going to take out a bunch of these equations up here. I'm going to take out this guy, and I'm going to take out this guy and this guy. So I just want the 5, 3. I'm going to take out this guy and this guy. And I've got a power of 1, a power of 2, and I've got the absolute value. Okay. So every time it was moving from 0, 0 to this, but when I when I graph them in, I've got a straight line, right? That's the straight line, or I have my parabola, or I have my absolute value graph. So they're a little different shape, but they all moved the same way. That vertex moved the same way. But when we're looking at this vertex, the sign of the x is -5, but it looks like it's positive every single time. So it's just because when we put this in, this was really -5. This was really -5. This was really -5. So it really is a -5, but when we put those two signs together, a negative makes this a positive. So it ends up looking like it's the opposite sign on the inside and the same sign on the outside when we're talking about this guy right here and how it moves from your origin. So that's the pattern, right? It's the opposite side on the inside and the same sign on the outside. It's moving left 5 and up 3. And that's how we move. That's how we talk about our translations of parent functions in algebra. Okay.